Lesson 4-3, Trigonometric Ratios, and in this lesson you learn to use trigonometric ratios to solve right triangles, and it's important because you can use trigonometric ratios to solve problems involving architecture and archaeology. Let's take a look at this real-world application on architecture. The Leaning Tower of Pisa, a bell tower in Pisa, Italy, currently leans 16.5 feet off-center. The tower was closed in 1990 in order for workers to attempt to stabilize the tower's foundation to prevent it from eventually collapsing. By 1994, the tower's lean had decreased about 2/5 of an inch. Okay, so if you were to draw a line from the top of the tower to the ground, a right triangle would be formed with the ground. If enough is known about our right triangle, okay, certain ratios can be used to find the measures of the remaining parts of the triangle. The ratios are called trigonometric ratios. Okay, trigonometry is one area of mathematics that studies angles and triangles, and you will dwell more on this when you get to high school. Okay, so when you talk about a right triangle, okay, there we are going to use our trigonometric ratios. But before we do that, let's look at this right triangle right here. This is triangle ABC, okay, and in this case A is the measure of the side opposite angle A. So if this is angle A right here, okay, A is the measure of the side opposite angle A. So the side opposite angle A is lowercase a, okay, which is in this case side BC. Okay, B is the measure opposite side angle B, and this is angle B right here. Okay, so the opposite side of angle B is right there, and it's in lowercase b, and side AC. Okay, and finally C is a measure of the side opposite angle C right here. Okay, which is also represented by lowercase c, and in this case it's going to be side AB. And if you notice, angle C forms a right triangle. Okay, and angle C will always be your right triangle. Okay, and the side opposite C will be known by another name, and we will discuss that in a few seconds. Okay, we know for a fact that A is adjacent to angle B and angle C. So if you look at side A, it is adjacent to angle B and angle C. Adjacent means next to. So when you see the word adjacent, just think of the phrase next to. Okay, so basically A is next to angle B and angle C. Okay, B is adjacent to angle A and angle C. So this is B, it's adjacent to angle A and angle C as well. And C is adjacent to angle B and angle A. Okay? The side opposite angle C, the side opposite angle C, the right angle, is called the hypotenuse. The other two sides are called your legs. So if you find the right angle of a triangle, okay, the side opposite that, in this case C, is called your hypotenuse, and the other two sides are called your legs. Okay, A is a leg, B is a leg. Okay, and one more thing, when you talk about your legs, okay, A is commonly the longer leg, B is your shorter leg. Okay, so when you look, try to distinguish between the legs A and B, okay, you can actually interchange them, but A is commonly the longer leg, B is the shorter leg. Okay, and these are the three trigonometric ratios we are going to talk about. Okay, the first one is the sine ratio. The sine of angle A is equal to the measure of the leg opposite angle A over the measure of the hypotenuse. So in symbols, sine A is equal to A over C, side A over side C. Okay. Cosine of angle A, the measure of the adjacent leg of the leg adjacent to angle A over the measure of the hypotenuse, or in symbols, cosine A is simply B over C. Okay, and tangent of angle A is the measure of the leg opposite angle A over the measure of the leg adjacent to angle A, or in symbols, tan A or tangent A equals A over B. Okay. Notice that sine, cosine, and tangent are abbreviated as sin, sin, cos, and tan respectively. But there's another method of memorizing your trigonometric ratios, and we call this from last year SOHCAHTOA. Okay, and SOHCAHTOA simply means that sine equals opposite leg over your hypotenuse, cosine equals your adjacent leg over your hypotenuse, and tangent equals the opposite side over the adjacent side. Okay, so write this down whenever you are doing trigonometric ratios and you'll be fine. Or if you want, you can memorize these. That's fine too. Okay, but it's easier to memorize SOHCAHTOA because when you get to high school, you are going to use this again. Okay, so let's move on and let's look at example number 1. Find the sine, cosine, and tangent of each acute angle around your answers to the nearest thousands. And this is our triangle. You're given the triangle with the measures of all the sides, and you want to find sine j. Okay, sine j. Okay, and if I'm going to put my SOHCAHTOA on this side, okay, just a reference. So let's find sine j. Sine j is equal to the opposite leg over hypotenuse, opposite over hypotenuse in my SOHCAHTOA. So I'm going to find angle j right here. This is angle j. Okay. And I'm going to look at the opposite side of angle j, which is 7, over the hypotenuse, which is 25. So this will be 7 over 25, or 0.280 to the nearest thousands place. Okay, and when I want to find cosine j is adjacent leg over hypotenuse, or adjacent over hypotenuse in my ka. So it's adjacent, which is 24, okay, and the hypotenuse, which is 25. So it's 24 over 25, or 0.960. Tangent j is opposite over adjacent, okay, TOA, and the opposite side of angle j is 7. Adjacent side of angle j is 24. So it's 7 over 24, or about 2.92. Okay, and let's look at angle L. Okay, and if you want to find angle L, okay, it's the opposite leg over hypotenuse, sine, opposite over hypotenuse, and if this is my angle L right here, okay, the opposite side is 24, the hypotenuse is 25, so it's going to be 24 over 25, or 0.960. Cosine L, okay, would be adjacent leg over hypotenuse. Okay, so cosine L will be adjacent leg, which is 7. Again, hypotenuse is 25, so it's 7 over 25, or 0.280. And tangent L is opposite leg over adjacent, my TOA, opposite leg, which is 24, over the adjacent leg, which is 7. 24 over 7, which will give us 3.429. And I want to direct your attention to these two things. Okay, look at cosine j and sine L. Okay, cosine j and sine L, they are the same. So when you talk about your right triangle. Okay, the uh, the cosine of the other angle will be the sine of the other angle. Okay, so and you have sine j here. If you are looking for cosine j, it will be the same as sine L. And if you also look at this one, let me remove that. You might think they're congruent. Okay, and if you also look at sine j here, they are going to be the same with cosine L. Okay, so a little bit of a little tip for you to think about, okay, and to remember. Consider the triangles QTV and MSO. Since corresponding side angles have the same measure, we know that the triangle QTV is similar to triangle MSO. Recall that in similar triangles, the corresponding sides are proportional. So in this case, when we have side M and side Q, they're both proportional. So M over Q is equal to S over T. Okay? So if we multiply each side by Q over S, M over Q times Q over S equals Q over S times S over T, you end up with MS equals QT. Okay, because we cancel the Q, cancel the S, M over S equals Q over T. So in this case, sine M is equal to sine Q. And that's exactly what we arrived at in this example right here, which are now all erased. Okay, let me bring that up again. There you go. There you go. Okay, and that's the reason why we were able to find sine M is equal to sine M is equal to sine Q, if that's the case. Okay, so in general, the sine of 64-degree angle in the right triangle will be the same as same number no matter how large or how small the triangle is. A similar result holds for cosine and tangent. What's it simply saying is that the value of the value of the angle will not change. It doesn't matter how big or how small the triangle is. The value of that will still be the same. So sine M and sine Q will always be the same no matter how big or how small the triangle is, for as long as the angles are the same. Okay? And you can also find a calculator. You can use a calculator to find the values of trigonometric functions or to find the measure of an angle. Okay? And if you want to find the value of sine 64 to the nearest 10,000, you use a calculator. Enter 64, click on sine, you end up with that number. Okay, and remember it has to be in degree mode. It cannot be in RAD mode. Okay, it's going to be a problem. Rounded to the nearest degree, to the nearest 10,000ths, sine 64 is 0.8988. Okay, and again, different calculators will require different approaches, because some calculators will have different instructions on how to find the sine. Okay, some calculators will you'll need to punch in SIN first and then the number. So figure out what calculator you have. Okay. So let's take a look at example number 3. Example number 3, find the measure of angle P to the nearest degree. Since the length of the opposite and adjacent sides are known, use the tangent ratio. So what does that mean? We want to find angle P in this case. Okay. To the nearest degree, we know that 5 is known and 9 is known as well. And then you ask yourself, if we are looking for angle P, how is 5 related to angle P? Okay, we know that 5 is the opposite side of angle P. And how is 9 related to angle P? We know that 9 is adjacent to angle P. So if we go back to our SOHCAHTOA, okay, we find these two sides, opposite and adjacent. Where can we find these two sides in that ratio? It's only in the tangent ratio, where you have opposite over adjacent. Okay, so that's the reason why we use the tangent ratio, opposite leg over adjacent leg. Okay, and we simply substitute that. Opposite leg is 5, adjacent leg is 9, and then use a scientific calculator to find the measure with a tangent of 5 over 9. Okay, so what do? We simply, okay, enter 5 divided by 9 equals equals, and then click on or press second, tangent to the -1, which will give us 29.054641. Okay, tangent to the -1 key undoes the original function. So basically this is your undo function of tangent. So you end up with an angle of to the nearest degree, which is around 29 degrees. Okay, and let's refer back to the application at the beginning of the lesson. Engineers working to correct the lean of the Leaning Tower Pisa could check the angle of a tower. Check the angle the tower makes with the ground to find any increase in the lean. Use measurements to find the angle to the nearest degree that the tower made with the ground. Okay, so this is our right angle right here. Okay, and we want to find that angle right there. Okay, so since the length of the adjacent side and the hypotenuse are known, use the cosine ratio. Okay, again, write down our SOHCAHTOA. Okay, and we want to find that angle. Okay, we know that this is 16.5 and this length is 179. We ask ourselves, how is 16.5 and 179 feet related to angle X? 16.5 is adjacent, okay, to angle X, and 179 feet is our hypotenuse. Okay, and if that's the case, we now have to use the cosine ratio, which is adjacent over hypotenuse. We have 16.5 over 179. Using a calculator, you end up with that number, or approximately 85 degrees. Again, we are using the cosine to the -1 button. After finding cosine of X, we simply use cosine to the -1 button, end up with an angle approximately 85 degrees. Now, each calculator that you will have a different you'll have a different way of using a particular calculator. So study your calculator how to find cosine to the -1. Okay, and that's how you answer number 4. And let's take a look at the next example, which is example number 5. Where is example number 5? It's probably at the bottom of example number 4. Yes, it is. You can find the missing measures of a right triangle if you know the measure of two sides of the triangle, or measure one side of one acute angle, and then find all of the measures of the sides and the angles in a right triangle. We call that solving the triangle. So finding all the measures of all of the sides of the angles of a right triangle is solving for the right triangle. So if we want to solve for triangle ABC, we notice that we don't know what angle C is, we don't know what side Y is, or side AB and side BC. So we don't know those two sides, and we don't know the measure of the angle. The easiest step right now is to find the measure of angle C. We know that the sum of all the angles in a triangle measure 180 degrees. So we simply have to add 42 plus 90 and subtract that from 180 degrees. Okay, or another way of doing this is we simply get 90 degrees. Okay, subtract 42 degrees and we get 48. Why is that? Again, because if we get 90 degrees, add 90 degrees, that'll give us 180 degrees. Basically what it's saying is this, that if I have 42 degrees and if I add this particular angle, it will come up as 90 degrees. So all I need to do is get 90 degrees, subtract 42, that'll be my angle C. Okay, so that's 48 degrees for that angle. We know that already. Okay, and then we want to find the measure of x first. Okay, if we want to find side BC, okay, and we want to use, let's say, angle A. Okay, you can use angle C, but let's use angle A for now. We begin to ask ourselves, how is angle A related to x and 22? So we write our trigonometric ratio. SOHCAHTOA, that's angle A. We want to find out how x is related to 42. That's the opposite side. And we know that this is 22 is the hypotenuse. So we use opposite and hypotenuse, or the sine ratio. So in this case, we do sine 42 degrees equals x over 22. And let's solve for x. Okay, multiply both sides by 22. Okay. But before we do that, let's find sine 42 degrees, which is 0.6691 in your calculator. Multiply that by 22, you end up with x equals 14.7. So x is approximately 14.7 inches. Okay, so that's BC is about 14.7 inches long. And let's find y this time. And finding y, we use 42 again. Okay, and we ask ourselves, how is y related to 42? And we know that y is adjacent, is an adjacent side to 42, and we still use the hypotenuse because those are the numbers that we know. You can use 14.7 and use another ratio. Okay, and it's going to be opposite and adjacent. You can use a tangent ratio here, but for this, for our purposes, we will use, okay, the adjacent. We know that y is adjacent to 42, and we know what the hypotenuse is, so we'll use the cosine ratio this time. And in the cosine ratio, okay, it is cosine 42 equals y over 22, adjacent over hypotenuse. And we find cosine 42, which is 0.7431, approximately y over 22. And then we multiply both sides by 22, we end up with y equals 16.3. Thus, side AB is about 16.3 inches long, and we have solved our right triangle. Okay? And let's take a look at this example right here. Okay, but before we do that, in the real world, trigonometric ratios are often used to find distances or lengths that cannot be measured directly. In these applications, you will sometimes use an angle of elevation or an angle of depression. An angle of elevation is formed by the horizontal line of sight and the line of sight above it. So the angle of elevation looks something like this. Okay, so that's your angle of elevation. You have a horizontal line, and your line of sight is above your angle of your horizontal line, and we define that as the angle of elevation. There's another angle which we call the angle of depression. It is formed by a horizontal line of sight and the line of sight below it. So the angle of elevation, the line of sight is above it, and the angle of depression, the line of sight is below the horizontal. Okay, so do not be confused about how to use angle of elevation, angle of depression, because if you are confused in using this, then your answer will be wrong in the succeeding problems. Okay, and let's see how we use this in this example 6. In 1994, Dr. Seuss, The Cat in the Hat, made its first appearance in Macy's Thanksgiving Day Parade. It took 36 people to maneuver the cat along the parade route. Suppose you were watching the parade, you noticed that two of the handling lines formed a right triangle with the ground. You estimated the angle of elevation to the bottom of the balloon to be 60 degrees. Again, know where to find your angle of elevation. So it's 60 degrees, and the handlers to be about 35 feet away from each other. Find the altitude of the bottom of the balloon to the nearest foot. Okay? So first things first, what do we know? You know that the distance from one handler to another, okay, and the approximate angle of elevation, you need to find the height from the handlers to the bottom of the balloon. It's going to be very difficult, okay, to answer this question if you don't draw it out or if you don't create an illustration. And the illustration should look something like this. These are your handlers, and this is what we want to find out: the distance from the handler to the top of the balloon, and the distance of both handlers, 35 feet. And your angle of elevation, the line of sight above it, above the horizontal, this is your horizontal, and this becomes your angle of elevation. If you make this your angle of elevation, you are going to get this wrong every single time. So remember, that's your angle of elevation. How do we plan to solve it? Okay, let h represent the distance to the bottom of the balloon in feet, and use the tangent ratio to solve this problem. Why are we going to use the tangent ratio? Because again, we go back to our SOHCAHTOA, okay, and we ask ourselves, if that's 60 feet, how is 35 related to 60 feet? 35 is an adjacent leg to 60 feet, okay, and h is the opposite side to 60 feet. And that's the reason why you use the tangent ratio, okay? So opposite over adjacent, okay? So we use the tangent ratio. That means tangent 60 degrees equals the opposite leg over adjacent leg. Substitute the values. The opposite leg is h. Adjacent leg is 35. Find the value of tangent 60 degrees, which is 1.7321 in your calculator. Multiply both sides by 35, end up with h equals 60.6235. Okay, so the height, the altitude of the bottom of the balloon is about 61 feet above the handlers. And if you want to check your answer, you can examine the solution by determining the angle of elevation in the equation tangent equals 61 over 35. And that's around 60.15 degrees. So the solution is pretty reasonable. All right, that's the end of our lesson. Thank you for watching.